Students, in this session we'll discuss to find shortest path from the given vertex to all other vertices using Dijkstra's algorithm. This is the graph that we are going to consider. The graph is having 7 nodes A, B, C, D, E, F and G. For the sake of example, I'll be taking A as the source node. Okay, this is the adjacency matrix from all node to all other node, and this is the D matrix. You can see that 999, if that is there, that means that it is not the neighbor node and there is no direct connectivity. Once you start this algorithm, once you start this node, mark that node, initial node. Right now our initial node, source node as A, mark that distance of that is also 0. Source node A is marked, its distance is 0. Okay. Among the remaining unvisited node, all these are unvisited. B, C, D, E, F are unvisited. From this you have to take the minimum one. Okay, for that I have to start checking I equal to 0, I equal to 1, I equal to less than n, because there are 7 nodes, n value is less than 7, that is 6. 0 to 6 you have to repeat. Okay, among the sentence goes like this: among the unvisited node, B, C, D, E, F, G are the unvisited node. In that unvisited node you have to take the minimum. Okay, I will be taking now the first node A, already visited, you skip it because this fails. Then B is unvisited, yes, minimum value is 99. Is it that less than the current minimum? No, so skip. C is the next node, its distance is 3, 3 less than 99, so right now minimum is this one. I don't know whether it is minimum or not. Right now it is minimum. Then go for the next node, cost is 4, which is not less than 3, skip. Next node is 4, cost is 4, not less than 3, skip. Cost is 999, not less than 3, skip. Sixth one, cost is 999, which is not less than 3. So among all the things, unvisited node, second, that C is the next least cost node. C is the next least cost node. Okay, so you have to mark this as visited. You have to mark that node as visited. From C, what are the neighboring node? From C we have got F, we have got B, we have got G, we have got E. Okay, E, 4 nodes are there, B, E, F, G. Then find the distance. We know how to reach to C. It takes 3, cost 3. Then what is the cost of reaching E? 3 plus 4, 7. What is the entry there already? It is 4. So no need to update this one. Why? Because this is costlier one. Direct path is 4, but this one if you take via C, then it is C. So no need to update. What about cost of reaching G? As there is no direct path from A to G, it was infinity. Now we have got a path from C to G, that is 5, and cost of reaching from A to C is 3. 3 plus 5 is 8. So 999 replaced by 8. Cost of reaching G is 8. Same way, there is no direct path from A to F. Earlier it was infinity. Now we have got a path 5. 5 plus 3 is 8. Update it. Other one is what is that? B. Cost for reaching B, earlier it was infinity. Now it is 5. 3 plus 2 is 5. You have to update. See, 99 is updated, and these updated things are highlighted with a yellow color. This is the second step when J equal to 1. So we have visited C, and the table is also updated. Now we have to go for next entry, J equal to 1. Among the remaining nodes, we have got B and D, E, F, G. B, D, E, F, G. Among these, which is the next least cost? That is D. From D, what are the nodes reachable? E is reachable. What is the cost of reaching from A to D? It is 4. What is the cost of reaching D to E? Is 2. This value is 6. But there is a direct path from A to 4, that is 4. 4 is 4 is the minimum one. So 4 is the minimum one. So if this value is bigger, then okay. If there is a better value, you replace it. Otherwise, no need to replace. Minimum among 4 and 6 is 4, that earlier value only. So no need to update. No need to update. There is no updation here. Value is retained. So that means D is visited. In the next step, among the remaining unvisited node, A already visited, B, C visited, D visited. Then remaining unvisited node, that is E. E is the next unvisited node because the cost is 4. From E you can reach G. From E you can reach G. Only one neighbor for E. C already visited. Okay. What is the cost of reaching from A to E? That is 4. What is the cost of reaching from E to G? That is 5. 5 plus 4 is 9. But already we have got the path from A to G through or via C. 3 plus 5, 8. Among these two, which is the minimum one? 8 is the minimum one. 9 is not the minimum. 8 is the minimum. So no need of updation as usual. A, this only retained. So this particular E is also marked. Okay, E is visited. All these are the visited node. We have got A already visited, C visited, D visited, E visited. Now we go for the next least cost node, that is B. What are its neighbors? One neighbor is F, other node neighbor is G. What is the cost of reaching to F? It is 2. What is the cost of reaching? What is the cost of reaching? Only one node, that is F only, 2. What is the cost of reaching to B? That is 5 plus 2 is 7. Earlier it was 8, now it is 7. So better value is 7. So you replace it. So F is now marked. F is marked. The remaining node, F is marked. The remaining node, that is G. Okay, no other neighboring node because all its neighbors are visited. So this is the final thing. Okay, so 0 to 0 cost is 0 from this table only. 0 to 1 is 5, 0 to 2 is 3, 0 to 3 is 4, 0 to 4 is 4, 0 to 5 is 7, and 0 to 6 is 8. So all these are the best value, better value, least value from the source node. Okay, the main goes like this. You can use constant, one adjacency matrix, two-dimensional array, then the variables, number of nodes, then source node. Read n value, read adjacency matrix, two-dimensional array, input source node, call DHA, Dijkstra algorithm by passing source node, adjacency matrix, and number of nodes. Okay, then the vertex node V, whether indicate whether it is visited or not, required number of loop variables, minimum value, and the D matrix. First, you get the copy from the adjacency matrix, that is our distance from source node to all other node. D source node is A means 0, D of 0 is the cost of reaching from A to A. D of 1 means cost of reaching from A to B. Cost of reaching to B, C is indicated by D of 2, like that. Okay, this is the D matrix. Initially, assume that is visited, source node is visited, and this cost is 0. Assume minimum cost right now. As I don't have any idea of minimum cost, I will be taking from that highest value, that is infinity. Among the remaining unvisited node, if the cost is less than this minimum, change the cost. Remember that particular node index in U. The minimum value, change it. and this is the that particular minimum node index. Okay, once you have got the minimum node, minimum distance, the node, mark that node as visited, print that one. Okay, then we have to update the table. How to update the table? You have to see each and every entries of D table from D equal to 0 to 6, D equal to D to last entry. If not visited, if there is no infinity, if it is not infinity only. Okay, if the minimum one, we have to update it. If D value is bigger than this one, then D is the minimum one, that update. If this, for example, current value is 7, and that by a particular this node is say 6, 6 you have to replace it. If d of I is greater than d of u plus c of 10, you replace it. So you have to repeat it for all the nodes. Okay, if there are 7, 6 times you have to repeat. Then once that is done, you will be getting a D table that you display it. Starting node, source node, the end node, I value, and its distance value. Okay, this is a adjacency matrix, this is a D table. So I'll brief again. Initially, A marked as visited. Among the remaining, the least cost is C. You mark it. Its neighbors are, one is F, other one is B, other one is G, other one is E. Four nodes. Entries for E, G, F, and B are updated. Entry for B, F, E, and G are updated. Updated only if the current value is less bigger than the computed value. Here earlier value infinity, now the value is 5, so 5 is smaller, replace it. Similar these two. Okay, you mark that C as visited. In the next remaining, D is the next node, mark that as visited. Its neighbor is E. Cost of reaching to E from D is 2. Cost of reaching from A to D is 4. 4 plus 2 is 6. Already if entry there is a 4. 6 is not lesser, so retain the old value. No change in that. And the next step after that, D, the next minimum cost is E. E, its neighbor G. Its cost of reaching to G from E is 5. 5 plus 4 is 9. 5 plus 4 is 9. And already we got a path from C. ACG is 8. 8 is better than 9. So 8 is retained. After that, next minimum cost is B. Mark that B. Its neighbor node is F. Cost of reach cost of reaching from B to F is 2. Cost of reaching from A to B is 5. 5 plus 2 is 7. 7. Earlier entry was 8 through via C. Now the entry is 7. 7 is better than 8, so 7 is changed. Okay. After that, you have after the then from the remaining, the list is F. Its neighbor is G. Cost of reaching from F to G is 5. Cost of reaching from A to F is 7. So G uh, G here cost of reaching is exceeding this one. 5, the better is there. 5 plus 3, 8 is there, so no need to change. The last node remaining is G. From G, all other nodes already visited, so no change in the D's. Okay, as an exercise, you take this directed graph. Okay, again here entries are 6, 8, 1 or 2 entries I can give, 1 row I can give. A to A is 0, A to B is 7, adjacency matrix. A to C is 12, A to D is 0, A to E 0, A to F 0. Okay, so can give one more entry. B to A is 0 because there is no arrow towards A. B to B is 0. B to B is 0. B to C 2. B to D 9. B to E infinity. So whenever there is no direct path, indicate by infinity. Infinity means 999. Okay, B to F also 999. So you try this one and obtain shortest path using Dijkstra algorithm. Thank you.